Spike template parameters. Opening a data file, I have one in my recent list, bursts. From analysis, I can choose New Wavemark to extract spikes from this continuous waveform. I can also right-click on the data and choose New Wavemark from the pop-up. We can now resize the new dialog to show more of the template bins. Double-clicking in the template area also resizes the display. I've already set up the trigger thresholds for this channel, deciding that just one positive trigger is necessary. To get the most out of spike template matching, we will need to go to the parameters dialog here and adjust the settings for creation of new templates and how spikes match to these templates. In the New Template section, the item number of similar spikes for a new template dictates how many spikes must match each other before a template is promoted from provisional status to one we can see and use for sorting. Template width as a percentage of amplitude modifies the initial boundaries or limits of all templates. The lines shown here in green indicate those limits. At 30%, the boundaries seem quite wide, so let's try 10% and apply it to new templates. Dragging the current triggered spike to one of the available template boxes creates a new template. The template limits are now much smaller after the change. Values of 20 to 30% should be a good starting point. To show and hide the template limits, we can press the button here. In the next item, if no spike occurs again within 1 in n count, then the provisional template decays and may be deleted. This helps to avoid promoting spikes to real status if they are very rare. Setting this value to a very high number during offline sorting would produce a template for every spike class. Matching a spike to a template now. We can scale the spike currently under consideration to help match the area of the target template. This helps if the spike class changes in amplitude and not shape. We scale the spike up and down, comparing it to the target template, and if it matches, we add it to the class. The item minimum percentage of points in template specifies how many data points must lie within the boundaries of the template. If more than one template fits, then spikes are matched to the template with the smallest error between the mean template and the spike. With Make Templates switched on, the system can provide its own templates based on the current parameters. Up until now, I have been dragging spikes from the oscilloscope view down to the template window. As you can see here, there are a number of data points that fall outside of the boundary. Let's change back to 60%, apply, and delete our current spikes. We should now have a better fit to the templates. Once templates are established, it can sometimes be better to match to the template with the smallest error and ignore the width. If you check this field, this sets the percentage of points that must lie in the template to 0% unless you are building templates. Template maintenance has 3 modes: Add All, Autofix, and Track. With Autofix, we can set the number of spikes that match the template before it is locked. That is equivalent to pressing the button here. Once locked, the template will not be modified by any new incoming data. Track follows slow shape changes. The contribution of each spike to the template decays as more spikes are added. Most users prefer Add All. In this mode, the first spike that forms the template has the most influence on the shape. As we now play through the data, you should be able to see subtle changes in the boundary layers as more spikes match the template. In effect, we are tuning the template shape. Slight adaptation of the template can be seen at the right-hand edge of this template window. To delete a single template, I click here. To delete all templates, we use this trash can button. Much more modification of the template will be seen if we set the maintenance mode to track and set a low number of spikes to follow. The template is now being modified more radically and changes shape to accommodate the incoming spikes. The waveform data section now. Here we control how the raw waveform data is processed into spikes. Waveforms are shifted by fractions of a sampling interval to align them with templates using linear, parabolic or cubic spline interpolation. Linear interpolation is the fastest, cubic spline interpolation is the slowest. For speed reasons, only linear interpolation is used while sampling. The next item is a high-pass filter. This reduces baseline drift. As a rule of thumb, it should be set to approximately the width of the oscilloscope display. Too low a value will significantly change the spike shapes. The last item in this section is remove DC offset before template matching. This subtracts the mean level from each spike before matching. Only the matching process uses this operation. The saved data is unaffected. It is usually better to use the high-pass filter unless you have a sudden DC drift in your baseline. One sometimes difficult to resolve situation is shown here. These bursts of spikes are decaying quite rapidly over a very short number of spikes. Instead of trying to automate the extraction of these spikes, I'm going to use a manual method. In this example, I'm going to call cursor 0 to the screen. I do this with Control and 0. As I move cursor 0, it latches automatically to each of the triggered spikes. With the largest of these events marked and shown in the oscilloscope view, I can drag it down to form a template manually. Moving to the right and selecting the second spike, forming another template. To the last event, and I drag another template shape. The three template classes are coloured, and it is obvious that they do not match each other. The trick now then is to form one template. Instead of merging the templates by placing one on the other, I'm changing the code to match the first template. As we allow the system to run through the data now, you can see the colours have changed to blue. New templates may appear that we consider to be part of the same spike class. We can merge these with our pre-existing examples, or we could change the parameters to accommodate more variation. If we merge templates, then the result is an amalgam of the pair. To preserve the destination template shape, we can force the template to be locked. Once you have your set of templates formed, pressing New Channel will produce the output to a wavemark channel. From the File menu of the dialog, you can save templates, and you can also load templates from either data files or from their associated resource files. You can also print the parameters you have used in generating templates, and also the templates that you have formed. Here I'm going to take the output to a digital document. If I now minimize Spike2 and call up the XPS file, you can see at the top the parameters and below the example templates, and finally all overdrawn. Hopefully this tutorial has given you a better insight into the parameters section of the wavemark dialog. We will be revisiting this area of Spike2 again soon.